Today, we're diving deep into a project that's part neuroscience, part art, and part history. It's all about finishing a map of human consciousness that was left incomplete for decades. Let's get into it.
So our guide for this whole journey is a semiotician, someone who studies signs and symbols. And get this, he sees himself less as a storyteller and more like a magician. He uses language itself, the very structure of it, to guide our attention. For him, every word, every sentence is basically a trick, a carefully crafted illusion designed to shape how we see the world.
And that really brings us to the core of the problem, doesn't it? Language is incredibly powerful, sure, but it has limits. I mean, how do you even begin to describe an experience that's happening entirely inside your own head? How do you create a map that everyone can use for a place that only you can visit? Well, this is the story of a quest to do exactly that.
Okay, so to really get what this quest is all about, we have to start with the tools. And for our guide, the most basic tool of all is how we even define art in the first place.
You see, in his world, just speaking is a form of semiotics. Language becomes this system of visual cues, a stream of mental pictures that build the stories that define who we are. We're literally stringing these images together, creating a little movie inside our own minds. And when you think about it that way, the act of speaking, that becomes art.
Now, this is where things get really interesting. On one side, you have this very fluid, personal idea of art, that it's any kind of unique expression that comes from the mind. But then you look at the other side, and you've got the U.S. Copyright Office with its super clear black and white list, fine art, photos, maps, you know the drill. This whole project we're talking about, it lives right in the gap between those two definitions.
And that gap leads us straight to a legendary chemist, a true pioneer who journeyed deep into the human mind, but left behind a map that was brilliant, yeah, but also unfinished.
So, meet Alexander Sasha Shulgin. This was a chemist who synthesized and, believe it or not, self-tested hundreds of psychoactive compounds. Shulgin was convinced these chemicals were like keys, unlocking a world submerged in human spirit. He saw it as this vast inner landscape, and he spent his entire life trying to explore it.
But here is the problem. Shulgin's notes were, well, they were deeply personal. They often read more like poetry than pharmacology. I mean, calling MDMA his low-calorie martini is amazing, but it's not exactly a scientific data point, right? His work was filled with this rich, subjective stuff that was powerful, for sure, but also incredibly hard for modern science to standardize or build on.
And this table right here illustrates the results perfectly. Because his notes were so narrative-driven, and because so much time has passed, key data is just gone. It's missing, or it's fragmented. For compounds like DOM, also known as SDP, what he wrote in his early lab notes doesn't quite match what he published later. The map has holes in it.
So how in the world do you solve a problem like that? Well, a team from multiple institutions is putting together this incredible technological toolkit. They call it a custom stack, to fill in those holes and finally complete Shulgin's life's work.
This is a massive collaboration between UC Berkeley, Stanford, and private tech companies. And they're building this custom stack, which is basically a system with 4 distinct layers. Each layer is designed to solve a different piece of this giant puzzle, from decoding Shulgin's old scribbles to recording brain activity in real time.
The first layer is called the Archival Extraction Engine. It uses some seriously sophisticated AI language models to scan Shulgin's dense, handwritten notebooks. Think of it like an AI-powered historian, basically translating his poetic descriptions into structured, searchable data that a computer can actually understand.
The second layer is the neural recording substrate. Now we're talking about cutting-edge hardware, ultra-soft, minimally invasive brain-computer interfaces that can capture neural activity at a resolution that was just unthinkable a few years ago. These aren't the clunky, rigid electrodes of the past. These are flexible probes that get high-density recordings without damaging brain tissue.
Okay, so you've got the historical data from the AI, and you have the real-time brain signals from the hardware. But that's just a flood of information, right? How do you turn that noise into something a person can actually look at and understand?
And this is where the human element comes roaring back in, thanks to 2 key people. First, you have Judy Fan, a cognitive scientist at Stanford. Her whole thing is studying how we use drawing to pull our internal thoughts out into the external world. And then there's Eric Seidenglantz, our semiotician guide, acting as the neuroaesthetic translation layer, basically bridging the gap between that raw data and actual visual art.
And Judy Fan just nails it with this quote. She says this whole process is about creating a shared visual language. It's about taking something that is purely internal, like seeing geometric patterns in an altered state, and making it something you can share, something we can all look at and talk about together.
And that brings us to the final and most crucial step, connecting all the dots. We're talking about linking the chemical compound to the neural firing patterns to the subjective artistic experience, all into one single unified picture.
So this slide right here, this is the whole ball game. For the very first time, this project lets researchers draw a direct line between the hard, objective data, like how strongly a chemical binds to a specific brain receptor, and Shulgin's original subjective rating of the experience, his famous +4 system.
The end result is, well, it's just breathtaking. The stack can take all that complex, high-dimensional neural data that's captured during a psychedelic experience and translate it, in real time, into generative visual art. It literally visualizes the invisible. The unfinished map that Sasha Shulgin started with a pen and paper is finally being completed, with silicon and software.
But an incredible new power like this brings with it some profound questions. When we can actually record, translate, and share the deepest workings of the mind, what does that mean for our cognitive liberty? What does it mean for the very idea of a private internal self? I mean, the power to draw the map comes with the huge responsibility of deciding who gets to see it. And in the end, our semiotician guide leaves us with this final, really provocative thought. He suggests that this whole act of communication, of shaping someone's perception through carefully chosen words and images, is more than just art. He calls it a recursion, a powerful force, a loop that literally rewires our reality. It's a reminder that maybe the most powerful tool we have for exploring the mind is the stories we tell about it.